All right, as we look at this, we're going to learn some new material this time, and it is multiplying and dividing rational expressions. And so there's really just two steps to this. You factor the numerator, you factor the denominator, and then you cancel out common factors. And the answer is what is left uncanceled. So I've got 6 examples I want to work through with you before we work on homework. So looking at example 1 here, we've practiced factoring for several weeks now, so you should be pretty proficient. But if we look at this, we've got a greatest common factor of 2x squared. So we're going to factor out a 2x squared from the top. And then we're going to be left with 4x minus 1. Okay? Because when I divide each of those by 2x squared, that's what I'm left with. In the denominator, we have a greatest common factor of just x. And then when we divide everything by x, we're left with 4x minus 1. Now, for a factor to cancel, it has to be identical. So what's in parentheses has to match exactly to cancel out that whole factor. Well, this does. So 4x minus 1 over 4x minus 1, anything over itself is 1. So that we say we cancel that out because really, instead of writing it, all that equals 1. So then we're left with 2x squared over x. Well, can any of that cancel? And you know that when you factor, or when you divide variables with exponents, you subtract the exponents, so 2 minus 1 is 1x. The other way to look at this, too, is 2x squared is 2 times x over x. So one of your x's is going to cancel, and your final answer is going to be 2x. Okay? So I can just subtract these exponents to get, and 2 over 1 is 2. And then x squared over x is x. So I can look at it by subtracting exponents, or I can kind of write all of them out and then cancel out however many x's would cancel. So my answer for number 1 is 2x. Let's go on to our next example. We're going to have to factor the numerator by grouping. So we'll have to group the first 2 and group the second 2. And so when we factor the greatest common factor out of the first group, that's going to be 2x squared. And that's going to leave me with x minus 3. And the greatest common factor in the second group is a 7, which leaves you with x minus 3. And the bottom is a difference of squares. Now again, I'm kind of running through this because we've had 3 weeks of factoring review. And we took a quiz, so hopefully you are getting better if you were still struggling with it. But a difference of squares, and you can use your factoring flow chart. Factors is x minus 3, x plus 3. Well, we have to write the top as factors. Right now, that's not written as factors yet. So that written as factors is going to be 2x squared plus 7 times x minus 3, and it's over x minus 3, x plus 3. And of course, what matches exactly? The identical factors are the 2 that are x minus 3. I can't factor anything else anymore, and so your final answer is 2x squared plus 7 over x plus 3. And that's as much as you can do. Now, I'm going to just warn you ahead of what you tend to do, what students tend to do is they look at this and they go, well, this x will cancel here to this x. You can't do that. Mathematically, those are factors, and the only way you can cancel a factor is if what's inside the parentheses matches exactly. They have to be identical to cancel. To be, because again, you're looking for something over itself to be equal to 1 because they match exactly. So those do not match exactly. You can't cancel the x's. You can't reduce any of the numbers. So be careful about that, because I know students always try to do that. So this would be your final answer, just like this. Let's look at example 3. Now we've got two things multiplied together, but we still have to factor everything first. So we've got several things to factor. If we look at this 2x squared minus x minus 3, we're going to go just right here to factor that. They multiply to be -6, add to be -1. So two numbers that do that would be -3 and +2. So that would be 2x squared minus 3x plus 2x minus 3. Group. Factor out an x, so you end up with 2x minus 3 and plus 1, 2x minus 3. Okay, so that's that first part of the numerator. So I'm going to go over here, and that's going to be 2x minus 3. I'm going to draw a line here. So this first numerator will factor as 2x minus 3 times x plus 1. All right, in the denominator here, okay, so we got 4 things we have to factor, and I'm going to kind of just number them. This is the first, the numerator. This is the second thing I'm going to factor. So when I factor that, I'm going to factor out an x, and that's going to leave me with x plus 1. So the second thing is going to be x times x plus 1 times, that dot means we're multiplying these. So this is the third thing I have to factor. And the greatest common factor in that third part is a 4x. And when you divide that, you're going to be left with x plus 1. So the third thing we'll factor is 4x times x plus 1. And this fourth part here, that second denominator, nothing, there's no greatest common factor, there's not an x squared, so it stays 2x plus 3. But remember, that has to be a whole, that's a whole fact, excuse me, it's minus 3. So let me change that to minus 3. And that's a whole factor that has to match exactly. So what matches exactly? And since they're all multiplied, we can cancel from one factor to the next. If these were added, that's not the case, but multiplication and division, you can cancel from one fraction to the next. So the 2x minus 3's will cancel. One of the x plus 1's will cancel. And this is not, sometimes y'all want to think of that this is 4x as a whole thing. It's 4 times x. Those are two different factors. 4 times x, and this is an x. So the x will cancel, which means that one. So you're left in the numerator. There's nothing left uncanceled in the denominator. So in the numerator, you're left with 4 and then x plus 1. And then that's your final answer. And leave it factored. You don't no need to distribute that 4 back across. Just leave it factored for your final answer. All right, so let's go to problem number 4. These are a little bit easier to factor because we don't have any coefficients in front. So for our first numerator, we can factor out a 4x. And that leaves you with x minus 1. In our first denominator, we've got 2 sets of parentheses. You've got x, and I've got a plus and a minus. And 2 numbers that will multiply to be 3 and add to be 2. So if it's a plus 3 and a negative 1, those will multiply to be negative 3 and add to be positive 2. And then the next one, the next numerator, you have x and a plus and a minus. And numbers that multiply to be positive negative 6 and add to be positive 1 would be a 3 times 2. That'll multiply to be negative 6. And then they add to be positive 1. And here we have a 4x, which again is two different things. It's 4 times x, but 4x. All right, so the 4's cancel. Now we go to canceling out. We've got everything factored. The x's cancel. An x plus 3 cancels. And remember, it has to be one numerator, one denominator. You don't cancel them both from the denominator or both from the numerator. One from top, one from bottom. And then the x minus 1 has a matching factor in the denominator. So the one that's left that we didn't cancel out is the x minus 2. So the answer is x minus 2. So if you can factor, you can multiply and divide rational expressions, because all you do is factor them and then cancel any factors that they have in common. All right, let's look at number 5. Now this is a division problem, and we need to think about that. If we make this a fraction, that's x plus 2 over 1. When you divide by a fraction, it becomes a multiplication, but you multiply by the reciprocal. So this problem is the same as x squared plus 4x plus 4 divided by x plus 3. The first fraction stays the same. We're going to change it to multiplication, and now it's 1 over x plus 2. So anytime you see a division, you take the fraction that immediately follows it, flip it over, and multiply. So let's factor. The only thing that needs to be factored is this first numerator. So that's going to be x plus 2 times x plus 2. That's multiplies to be 4 and adds to be 4 over x plus 3 times 1 over x plus 2. Okay, so only one of these x plus 2's will cancel, because you have to have one of each, numerator and denominator. So your final answer is going to be x plus 2, that's all that's left in the numerator, over x plus 3. That's all that's left in the denominator. Now again, some of you are going to want to cancel those x's out and tell me the answer is 2/3. It is not that. You have to match the whole factor, that whole x plus 2, because say your x has some number value, and so whatever, we don't know what that is, but we can't cancel it out. Okay, you have to leave it as an entire factor, and unless they're identical, you do not cancel them. Okay, let's go to our, we have 2 more examples. Again, this is a division. Again, we have to do a lot of factoring. So we're going to factor, I think we already factored the 2x squared minus x minus 3, but I forgot what it was, so we'll do it again real quick. So it multiplies to be negative 6 and adds to be negative 1. And so that's going to be negative 3 and positive 2. If you want to do the box method instead of the grouping, I'll just throw that in there for an example. You have 2x squared, you have negative 3, and then you're going to put a negative 3 here and a positive 2 here. Okay, so the way to get 2x squared is x times 2x. And then if I put a negative 3 out here, negative 3 times x is negative 3. If I put a 1 here, 2x times 1 is 2x. Those should have x's in them. And then negative 3 times 1 is negative 3. So the factors for the first one, I'm going to draw this line here. My first numerator will factor is 2x minus 3 times x plus 1. Now my first denominator, I can factor out a 2, and that gives me x squared plus 4. The only thing I can factor out of that is a greatest common factor. Now we've got to flip the second fraction. We want to put it as a numerator. We want to flip it, so I'm going to make it a times. And I can factor out a 2, which is going to give me x to the 4th minus 16. The denominator becomes the numerator. And now let's look at, we want to multiply to be negative 12 and add to be positive 1. So that's going to be a 4 and a negative 3. So again, if we do the box, you're going to do 2x squared and 4x and negative 3x and negative 6. The two numbers we figure out go in the one diagonal, and the first and last term go in the first diagonal. So I'm going to put a 2x here and an x here. Put a 2 here. 2 times 2x is 4x. A negative 3 here. Negative 3 times x is negative 3x. And your final check here, negative 3 times 2 is negative 6. So that factors to be x plus 2. And 2x, where is it? 2x minus 3. Okay. Well, what we have right now, we can look and cancel some of this out right now. We can cancel out this 2. We can cancel out the 2x minus 3. But this right here can factor some more. So we can't say we're finished. Okay, so we still have an x plus 1 over x squared plus 4. Over here we still have an x plus 2. Now x to the 4th minus 16 is a difference of squares. So that's x squared minus 4 and x squared plus 4. Okay, but x squared minus 4 will factor as x minus 2, x plus 2. So that will factor even further. So now we can cancel out this x squared plus 4. And we can cancel out this x plus 2. And so what's left uncanceled is x plus 1 times x minus 2. And that would be your answer for that one. Nothing's left in the denominator. The only two factors that are left are in the numerator. Okay. Let's move on to the last example. And this has 3 different terms. So this is a lot. So I'm going to factor some things that I know will factor. We've got these first 2 are kind of tricky, so we'll do the box on them, and then I'm going to erase it so I have plenty of room. So we want to multiply to be 6 and add to be 5, so that's 3 and 2. Okay, so that's going to be 2x squared plus 3x plus 2x plus 3. Group them. This factors an x. Gives me 2x plus 3 plus 1, 2x plus 3. And I'm doing this in a hurry just because I want to show you the work, but you can slow it down if you need to. So this first numerator is going to factor as 2x plus 3 times x plus 1. Okay. Now I'm going to erase all that and do the first denominator. And that's that's going to multiply to be 12 and add to be 7, so it's 4 and 3. So we have 2x squared plus 4x plus 3x plus 6. Group them. We have 2x gives me x plus 2 plus 3 is x plus 2. So my two factors are 2x plus 3 and x plus 2. Okay. So now I'm going to erase that. So that's that first fraction has been factored out. Now notice the second fraction has a division. So I'm going to change it to multiplication and flip the fraction. So now the x squared minus 4 is on top, but that's going to factor the difference of squares as x minus 2, x plus 2. And the other one is a sum of cubes, so that's going to be x plus 1 times x squared plus x plus 1. Okay, that's that factorization that we learned for a sum of cubes. Now this multiplication, I don't flip, so after this last one, excuse me, I should have changed the sign on this one. This should have been a minus. Okay. There's nothing that will multiply to be 1 and add to be negative 1, so I can't factor this fraction or this numerator, so it's going to stay x squared minus x plus 1. And in the denominator, you can factor out a 2, so that leaves you with x minus 2. So I've got all multiplication. I've just flipped the fraction on the division and changed it to multiplication. Now we look for factors that match that are identical. So 2x plus 3, 2x plus 3, that cancels to be 1. Here's an x plus 1 and an x plus 1. Here's an x minus 2 and an x minus 2. Here's an x plus 2 and an x plus 2. And then all of this matches all of this, so that whole thing cancels here. So the only thing we have left is that 2 right there that we didn't cancel. Well, if everything cancels out in the numerator, there's a 1 there. So my answer is 1/2. So all of that canceled out, all of that big problem, the answer is 1/2. All right, so I went through this very quickly. It's still 22 minutes long. So stop and start it as you need to and use these as examples.